Welcome. I am the Body Whisperer, and I am glad you are here. Let us go quietly inside you to meet Lymphatic Lars, one small part of you that keeps working through the night while you sleep. While you sleep, Lymphatic Lars guides the brain's overnight glymphatic flush, a quiet current of cerebrospinal fluid that drifts through widening cell spaces and carries the day's metabolic waste gently away. But first, let us settle in together. Find a comfortable position. Let your arms grow heavy, your legs, your shoulders. Take a slow breath in and let it go. One more. In and release. Good. Now, while you rest here doing nothing at all, something quiet is happening inside you. Your body is working. It always is. Every hour of every day, without ever asking for thanks. I want you to get to know it a little better, to listen to it, to feel it, to appreciate it. Because the more you understand the quiet world beneath your skin, the more at home you feel inside your own body. There is nothing you need to do now. Nowhere to be, nothing to figure out. Just breathe. Close your eyes if you have not already, and let us begin. There is a quiet piece of work going on inside you right now, and it has been going on every night of your life. You probably never noticed it. That is, in a way, the whole point. While you sleep, while the body goes still, and the breath slows and the room gets dark, a small, steady current begins to move through your brain. Not a dramatic surge. Not a flood. Just a slow, deliberate drift of fluid, winding its way through the spaces between cells, carrying away the day's leftovers. Quietly, methodically. The way a good cleaning crew always works, while everyone else is gone. The one doing that work is Lymphatic Lars. Lars runs the brain's overnight cleaning system, a network of channels and spaces that researchers have given the name the Glymphatic system, meaning a lymph-like drainage route built into the brain itself. The rest of the body has a proper plumbing network for this kind of job. The brain, sealed inside its skull, does things its own way. It routes a fluid, cerebrospinal fluid, which is the clear liquid that cushions and bathes the brain through the tissue itself. That fluid moves in, picks up the metabolic waste that a long day of thinking leaves behind, and carries it back out. Lars is the one who keeps that process moving. He is not a dramatic figure. He does not rush. He has been doing this job since the first night of your life, and he will still be doing it quietly, without complaint, on the last. He simply shows up when the conditions are right, runs the fluid through, and goes home before you wake. The conditions, it turns out, are very specific. Lars needs you asleep. This is worth sitting with for a moment, because it is not just a convenience, It is the whole architecture of the system. While you are awake, the brain is busy. Neurons are firing. Signals are traveling. The spaces between the brain cells stay relatively tight, crowded with all that activity. There is not much room for a proper rinse. The fluid can move a little, but only a little. Lars waits. When sleep arrives, real sleep, deep sleep, something shifts. The cells of the brain actually draw inward, just slightly. The spaces between them open up, and suddenly there is room. The cerebrospinal fluid moves more freely, winding into corners it could not reach before. The current picks up. The cleaning begins in earnest. This is the one true thing about the brain at night. It is not simply resting. It is being washed. The brain is one of the most metabolically active organs in the body. It runs almost constantly, burning fuel, sending signals, building memories, processing everything the day threw at you. And like any engine that runs hard, it leaves residue. One of those residues is a protein called beta-amyloid, a substance that forms naturally as a byproduct of all that neural activity. It is not a foreign invader. It is just metabolic exhaust. The brain makes it. The glymphatic system clears it. That is the arrangement. While you are awake, the arrangement is tilted. Production is running. Clearance is slower. The residue drifts. By evening, there is a fair amount of it waiting. Lars knows this. And then sleep comes. The space is open, and the fluid moves through, and the clearance finally catches up. Researchers studying this process in animals found that the clearance of substances like beta-amyloid increases substantially during sleep compared to wakefulness. The mechanism makes sense. More space between cells, more fluid flow, more efficient removal. The brain uses the night to clear what the day produced. That is why the fog of a badly slept night is not imagination. Something genuinely did not get finished. The rinse was cut short. The current ran too briefly, through spaces that never fully opened, in a brain that never quite reached its deepest cleaning hours. Lars showed up. The work was simply incomplete. A full night changes that. A full night gives Lars the hours he needs, especially the deep, slow hours that come early in the night, when the brain settles into its most restorative rhythms and the spaces between cells reach their widest. That is when the current runs best. That is when the fluid moves farthest. And right now, as the room goes quiet and the body begins to settle, that is exactly where things are heading. The brain is a strange and beautiful place to spend a night. It sits tucked inside the skull, roughly the weight of a ripe cantaloupe, soft as firm tofu, running on a fuel supply delivered by a web of blood vessels so fine that many of them are thinner than a human hair. It is the most complex object in the known universe, and it needs a wash just like everything else. Lars does not find that funny exactly. He finds it appropriate. The most complex thing in the universe still makes a mess at the end of a long day. Of course it does. So does everyone. The fluid is beginning to move now, not quickly. There is no hurry. The night is long, and Lars is patient, and the current knows the way. Let your breath go easy. The body is already doing what it needs to do. The brain is settling into the dark. The spaces are beginning to open. The work has begun. Let the breath out slowly. And again. There is no right way to do this. There is only softer and then softer still. The spaces are beginning to open. The work has begun. Now, here is the thing that took scientists a long time to understand. The brain does not have the same plumbing the rest of the body has. Most of the body's tissues are served by a network of tiny vessels, the lymphatic system, that collects cellular waste the way a town's drainage pipes collect rainwater. The brain is sealed off from that system. The skull keeps it protected, but protection comes at a cost. The ordinary drainage routes never make it inside. So the brain built its own solution. And the solution is elegant in the way that truly good design usually is. It uses what is already there. The brain is bathed in a fluid. A clear, slow-moving liquid called cerebrospinal fluid that surrounds the brain and the spinal cord and keeps them cushioned. You already knew the fluid was there. What you may not have known is that it also moves through the brain itself, flowing along the outside of blood vessels, the way water flows along the edge of a pipe. Those vessels have a kind of sleeve around them, a narrow channel, and the fluid travels through that sleeve down into the brain's deeper tissue. That sleeve, that channel around the blood vessel, is called a perivascular space, meaning a space that wraps around a vessel. Lars lives and works in those spaces. They are his corridors. His entire network is built from them. Here is what makes this remarkable. While you are awake, those corridors are narrow. The brain's cells are full of activity, slightly swollen with the business of the day, and the spaces between them are tight. The cerebrospinal fluid still moves, but slowly, constrained, unable to push very far into the tissue. Lars can nudge things along the edges. He cannot reach the middle. But in sleep, and especially as sleep deepens, something changes in the cells themselves. They pull water inward through tiny molecular doorways, called aquaporin channels, meaning water-passing gates. The cells adjust their internal volume, and when they do, the spaces between them widen, not dramatically, not like a room suddenly opened up. More like a path through tall grass that has been walked down just enough to let someone through. That is enough. Lars does not need a highway, he needs a path. And through that wider path, the cerebrospinal fluid begins to move with real purpose. It travels in along the arteries, down the perivascular sleeves, pushes through the widened spaces between cells, picks up whatever the day's work has left behind, and then carries it back out along the veins. And throughout, the direction matters. The flow has a logic to it, a polarity, the way a river always knows which way is downhill. What it carries out is the ordinary residue of thinking. The brain runs on glucose, a simple sugar, and when it burns that fuel to power a thought or hold a memory, or move a hand, it leaves chemical traces behind. Some of those traces are small and dissolve easily. Others are stickier. There is one in particular, a protein fragment called beta amyloid, that tends to clump if it is left to accumulate. The brain produces it constantly as a normal part of its daily business. It is not a sign of anything wrong. It is simply a byproduct, the way ash is a byproduct of a fire. The fire is necessary. The ash just needs clearing. Lars clears the ash. The cerebrospinal fluid, moving through those open spaces, takes the beta amyloid with it, along with other metabolic byproducts, the spent molecules and loose protein fragments that a day of hard thinking inevitably produces. It carries them down and out of the brain into the body's broader circulation, where they are eventually broken down and disposed of through the liver and kidneys. All of that happens while the brain rests. Not because rest is passive, because rest is the condition that makes the work possible. Here is something worth sitting with. During the hours you are awake, your brain is running a kind of controlled deficit. The cleaning cannot keep up with the producing. The fluid moves too slowly through spaces that are too tight. Waste accumulates, not catastrophically, not suddenly, but steadily, the way dishes pile up in a sink during a long, busy day. The brain tolerates this. It is built for it. But there is an understanding, a biological arrangement going back further than memory, that the night will come, that the spaces will open, that Lars will finish what the day could not start. Sleep, then, is not the brain going quiet. It is the brain making a very specific trade. It gives up awareness, the alertness that helps you navigate the world, in exchange for access. Access to its own interior. A chance to be cleaned all the way through. Lars knows this. The fluid is moving now. The corridors are open. The cells step back just enough to let the current pass, and the current is doing what currents do, finding its way through every available channel, carrying what it finds, moving always toward the exit. It is not a dramatic process. That is the part that surprises people when they first learn it. They expect the brain's self-cleaning to look like something, a surge, a sweep. Instead, it is this: a slow, clear tide moving through narrow spaces in the dark, not a flood, just a current. Nothing is required of you now. Not thinking, not planning, not remembering. All of it can wait until morning. Not a flood, just a current, and that current has a direction. This is the part that tends to surprise people once they learn it. The fluid does not wander. It does not slosh around randomly in the dark, hoping to bump into something useful. It moves along a route. A deliberate, structural route that the brain itself maintains, rebuilt every night, dissolved every morning, and rebuilt again the following night. Lars does not improvise, he follows the map. Here is how that map works. The brain is threaded with blood vessels, the way any living organ is. And around each of those vessels, wrapped loosely around them the way a sleeve wraps a wrist is a narrow channel of open space. Fluid moves through that channel. Researchers named these the perivascular spaces, meaning simply the spaces that live beside the vessels. They are not large, but they do not need to be. What matters is that they are continuous. They form a connected network, a path that runs alongside the brain's entire vascular tree, from the surface of the brain down into its deepest structures. Lars knows his way around this network, the way a river knows its banks. During the day, those channels exist, but they are somewhat compressed. The brain cells are plump and busy, full of water, swollen with the activity of thinking and signaling and managing everything a waking mind manages. There is not much give. The fluid moves, but slowly, constrained by how little space the tissue allows. Then sleep arrives, and something changes in the cells themselves. Embedded in the membrane of certain brain cells, the support cells called astrocytes, which are the brain's own structural scaffold, there are tiny protein gates. Gates that open and close to let water pass in and out of the cell. These gates have a name, aquaporin channels. Aqua meaning water, porin meaning passage. Water passage gates, built right into the cell wall. In deep sleep, those gates adjust. Water redistributes. The cells themselves become slightly smaller. Not dramatically, this is biology, not origami, but measurably, meaningfully smaller. And when the cells shrink even a little, the spaces between them widen. The channels along the blood vessels open up. The perivascular sleeves expand just enough. Just enough for the current to move. This is the quiet engineering at the heart of what Lars does. He does not generate the current himself. He benefits from a structural change that the sleeping brain has already made for him. The brain, in its wisdom, rearranges its own geometry to let the work happen. It opens the doors, Lars walks through. The cerebrospinal fluid, the clear, slow-moving fluid produced in a set of chambers deep in the brain called the ventricles, enters the perivascular spaces from the outer surface, riding alongside the arteries as they push inward with each heartbeat. There is a gentle pulse to it. The heart beats, the arteries expand slightly, and that tiny pressure nudges the fluid forward, deeper into the tissue. A pulse-driven tide, slow and steady, moving inward through the brain with every beat. And as that fluid moves inward through the tissue, it picks things up. The metabolic waste that accumulated through the day, the spent proteins, the used-up signaling molecules, the ordinary debris of a brain that has been thinking since morning, that waste floats in the fluid between cells. As the cerebrospinal fluid moves through, it collects what has been left behind, the way a slow current through a forest floor carries fallen leaves. Not swept up violently, carried along gently by the movement of water through space. Among what gets carried, a protein called beta-amyloid. The brain produces it as a natural byproduct of neural activity. It is not a sign of anything wrong. It is simply what active neurons leave behind, the way candles leave wax. Through the day, it accumulates in the spaces between cells. Through the night, Lars collects it, and the current moves it onward, away from the tissue, toward the veins, and eventually out of the brain entirely. Lars knows this. He has always known this. The science simply caught up to him in recent decades, when researchers began to map what the sleeping brain was actually doing with its fluid. What they found was not rest in the way people imagine rest. It was work. Deliberate, structural, necessary work. The kind of work that can only happen when the brain stops doing everything else. Because here is the thing about a busy kitchen. You cannot mop the floor while the cooks are still moving. You have to wait for the last order to go out. You have to wait for the room to empty, for the movement to stop, for the shift to finally end. And then, only then, can the floor get clean. The brain is exactly that kitchen, and Lars is exactly that mop. The fluid moves inward along the arteries. It picks up what has accumulated. It travels outward along the veins. And somewhere in that slow, dark, pulse-driven current, the brain is being rinsed, quietly, continuously, without drama or announcement. It did not ask for applause. It simply needed the night. Let your shoulders drop a little further. Let the back of your neck soften. The pillow is doing the work now, not you. There are cells in the brain that nobody talks about much. Not the neurons. Those get all the attention, all the credit for thinking and remembering and making sense of the day. The cells that Lars relies on are quieter than that. They are called astrocytes, and they are not famous, but they are everywhere. Spread through the brain's tissue like a fine net, arms outstretched, each one touching blood vessels on one side and neurons on the other. They are the brain's support staff, maintaining the chemical balance, cushioning the neurons, and crucially, managing the water that moves between cells. That last job is the one Lars cares about most. Think of astrocytes as the walls of a corridor. When those walls are thick and swollen, the corridor is narrow, and the fluid that Lars needs to move can only trickle through. But when those walls slim down, when the astrocytes reduce their volume, the corridor opens. The fluid finds room. The current can finally build. This is what happens in deep sleep. The astrocytes do not disappear. They simply step back. Their membranes are covered in tiny doorways, protein channels called aquaporins, meaning water-passing gates. And through those gates, water moves out of the cells and into the spaces between them. The cells themselves become a little smaller. The intercellular space, the gap between one cell and the next, quietly widens. And the whole geography of the brain shifts just slightly, just enough. Just enough is all Lars needs. The change is not dramatic. The brain does not hollow out. The cells do not shrink visibly. But the difference between a snug fit and a working channel is not always a large one. A hallway that was crowded becomes passable. A passage that was passable becomes a current. And a current, if it is steady and consistent through the long hours of sleep, can carry a great deal. That is the part worth sitting with. Lars does not rush. He does not pour something forceful through the tissue and call it clean. The fluid moves slowly, and it moves by design, entering near the arteries, drawn inward by each quiet pulse of the heartbeat, then spreading through those widened intercellular spaces, picking up what the day left behind and drifting out again along the veins. The astrocytes, by stepping back, make that whole journey possible. Here is the thing about beta amyloid. It is a protein, a fragment of a larger molecule, and the brain produces it as a natural byproduct of its work. Not a mistake, not a malfunction. Simply waste, the ordinary residue of neurons firing and communicating through the long hours of waking life. The brain makes it, and the glymphatic system, Lars's system, is one of the main ways it gets cleared away. While you are awake, that clearance is modest. The astrocytes are occupied, the spaces are narrow, and the fluid cannot move with any real momentum. Through the night, in deep sleep, the astrocytes open the corridor, the fluid flows, and the beta amyloid is carried along with it. It accumulates during waking hours. It clears during sleep. That rhythm, accumulate, clear, is not broken biology. It is biology working exactly as it was built to work. Lars does not worry about the accumulation during the day because he knows what the night is for. Lars knows this. There is something else the astrocytes do, almost as a side effect of their stepping back. When the intercellular spaces widen, the brain's electrical activity quiets. Not completely. The sleeping brain is never silent, cycling through its own slow rhythms, but the dense, crackle and hum of waking cognition settles into something slower and more open. The neurons are still talking, but not all at once, not urgently. The brain, in deep sleep, switches from a crowded conversation to something more like a slow, patient monologue. And in that quieter state, the fluid moves better still. The biology here fits together the way good design tends to. The cells shrink, the spaces open, the fluid moves more freely, the electrical activity slows, and that slower activity creates fewer interruptions to the current. Each piece enables the next. Lars did not design this system, and he would not claim credit for it if he could. He simply works within it, methodically, starting where the fluid enters and following it through to where it leaves. Astrocytes, it turns out, are doing two jobs at once, supporting the neurons while they are awake and making way for the fluid while they sleep. Two roles, one cell type, governed entirely by the state the brain is in. Awake, they hold their shape and tend their neurons. Asleep, they yield a little, and that yielding is the whole foundation of the night's cleaning. Not a small thing, for a cell that nobody tends to mention. And so the corridor opens. The fluid finds its way. The hours before morning pass in this slow, efficient current, not rushed, not dramatic, simply steady. Lars moves with it, as he always does, working the geometry the sleeping brain provides. It did not need to be complicated. It only needed to be given the time. There is nowhere else you need to be. Nothing you have forgotten. The night is long, and it belongs to you. There is a rhythm underneath all of this. Not the rhythm of the heart, though the heart plays its part. Something slower. Something that only appears when the brain is truly, deeply, unambiguously asleep. It is called slow wave sleep. The name is almost too plain for what it describes. During deep sleep, the brain's electrical activity shifts from the busy, scattered firing of wakefulness into something more like a tide. Long rolling waves, measured, patient. Moving through the brain the way a swell moves through open water, not rushing anything, not forcing anything, just passing through. Lars knows this rhythm the way a sailor knows the sea. When those slow waves arrive, the brain does something it cannot do any other time. Neurons, the brain's own signal-sending cells, tend to quiet together rather than separately. They fire, then pause. Fire, then pause. A collective breath in and a collective breath out. That coordinated quiet is the signal that the gate is open. The cleaning current can move. Here is why that matters. During wakefulness, neurons are doing what neurons do, firing constantly, independently, in overlapping patterns. The brain is full of local traffic. There is no unified pause, no shared moment of stillness. And without that stillness, the fluid cannot flow through as freely. The tissue stays crowded with activity, and the spaces between cells stay relatively narrow. Lars can do very little cleaning in a crowd. But deep sleep changes the geometry. When the slow wave arrives and neurons enter that coordinated pause, something happens in the fluid that surrounds them. A wave of fluid, cerebrospinal fluid, the brain's clear internal rinse water, moves inward through the perivascular spaces, driven by the pulse of the arteries and drawn further by the newly widened channels between cells. The slow electrical wave and the fluid wave move together. Like a tide that rises each time the brain goes quiet. Researchers found this coupling, and it stopped them for a moment. Not because it was strange, because it was elegant. The brain had arranged things so that the very state of sleep that allowed cleaning to happen was also itself, producing the motion that did the cleaning. The slow wave is not just a sign that deep sleep has arrived. It is part of the mechanism. It helps drive the fluid. Think of it like a bellows. When the sleeping brain's slow waves roll through, the subtle pressure changes they create add force to the fluid's movement. The cerebrospinal fluid shifts inward with each wave, collects what it finds, and moves outward again. Not dramatically, not in a rush. The whole thing is unhurried, which is exactly how it should be. A good rinse is not a power wash. Lars knows this, in the unhurried way of someone who has never once been in a hurry. What this means in practical terms is something worth sitting with for a moment. The cleaning is not merely permitted by sleep, it is synchronized with sleep. The slow waves are not just evidence that the brain has stepped back from waking work. They are participants in the cleaning itself. The brain does not simply go quiet and wait for Lars to work. The brain, in going quiet, actively enables the flow. That is the thing nobody quite expects the first time they hear it. We tend to think of sleep as the brain powering down, as absence, as the lights going off And in a narrow sense, yes, the lights of conscious awareness do dim. But underneath that dimming, a different kind of coordination is happening. The slow waves are still organized activity. The fluid is still in motion. Lars is still working. The brain, while being rested, is also being washed. Both of those things are true at once. The slow waves come in cycles through the night. Deep sleep appears early, in the first portion of a full night of rest, and the slow waves are at their strongest then. Lars uses those early hours well. The flow is good. The channels are open. The cerebrospinal fluid moves in, does its quiet work, moves back out. As the night progresses, sleep becomes lighter in places, then deepens again. Each return to deep sleep brings another round of slow waves, another turn of the current, another pass through the tissue. The cleaning is not a single event. It is a series of gentle rounds, each one adding to the last. By the time morning approaches, the work of many rounds has accumulated into something substantial. Not because any single round was dramatic, because there were enough of them. This is why a full, uninterrupted stretch of sleep matters more than most people realize. It is not simply about getting enough hours in a general sense. It is about giving the slow waves time to arrive, time to repeat, time to let the fluid do its full circuit through the brain's tissue. Each interruption is not a catastrophe. It is just a pause where the current stops, where Lars sets down his work and waits, and where the wave, when it finally returns, starts again from the beginning. Patience is the whole of his character. The slow waves, the widened spaces, the fluid moving in time with the brain's own quieting. It was not a simple system. But simplicity was never really the point. The point was that every part of it fit. It did not need to be simple. It only needed to fit together. Your arms are heavy. Your legs are heavy. That heaviness is the good kind, the kind that means the day is finally over. So the system fits together. The fluid moves, the space is open, the current runs, but it helps to know what the current is actually carrying. Lars does not work in the abstract. He moves things. Specific things. And the most talked about thing he moves, the one researchers keep coming back to, is a protein called beta amyloid. Here is what beta amyloid is. The brain, in the ordinary course of a day, produces proteins, small biological molecules, built from chains of amino acids that the cells use to do their work. Most of them get used, recycled, or broken down without incident. Beta amyloid is a fragment that gets left behind, not because something went wrong. Simply because the brain is busy and the fragment is a byproduct, the way a candle leaves a little ash alongside the light. During the waking hours, beta amyloid accumulates, not dramatically, not quickly. Just steadily, the way dust settles on a shelf when no one is running the cloth over it. The brain is occupied. Lars is waiting. The fragment builds up quietly in the spaces between cells. And then sleep comes. The slow waves roll through. The astrocytes let the water shift. the spaces widen. The cerebrospinal fluid, the brain's clear, simple rinsing fluid, begins to move inward from the arterial side. And as it flows through the widened intercellular space, it picks up what is there. Beta amyloid. Other metabolic fragments. The ordinary leftovers of a day of thinking. The current carries them outward, along the venous side, and eventually out of the brain, entirely into the body's broader drainage. Not a purge. Not a pressure wash. More like a slow, thorough rinse. The kind where the water runs clear at the end. Not because it was forced, but because there was finally time. Lars knows this. What is interesting, genuinely interesting, in the way that makes you want to sit quietly and think about it, is that the brain does not merely tolerate this process. It appears to have been built around it. The geometry of the intercellular spaces, the placement of the aquaporine channels, the timing of the slow waves, the pulse-driven entry of fluid along the arteries. None of these things are accidents of architecture. They are a system. Each part addresses exactly the limitation of the part before it. The skull is rigid, so there can be no swelling of lymph vessels inside it. The cerebrospinal fluid is already present, so it becomes the rinsing medium. The astrocytes are already wrapped around every blood vessel, so their membranes become the valves that control the flow. The slow waves of deep sleep are already cycling through, so they become the pump. The brain did not add a cleaning system. It turned what it already had into one. That is worth pausing on for a moment. Every other organ in the body has a relatively straightforward drain, lymphatic vessels running alongside the blood supply, collecting fluid and waste and routing it toward processing. The brain, sealed inside bone, could not use that design. So it found another one. It used the fluid it was already bathing in. It used the cells already lining every vessel. It used the electrical activity it was already generating. The solution was native, built from what was there. And it runs. This is the part Lars finds most elegant. It runs almost exclusively during sleep. Not because sleep is when the brain finally gets a chance to clean, but because sleep is when all the conditions for cleaning are simultaneously met. The slow waves are running. The astrocytes have opened the channels. The spaces are wide. The arterial pulse is steady and rhythmic. Everything that needs to be true at the same time is true at the same time. Awake, some of these conditions exist. The pulse is there. The fluid is there. But the slow waves are absent. The astrocytes are occupied with supporting active neurons. The spaces are narrower. The geometry is wrong. The current, without the geometry, slows to something closer to a trickle. So it waits. Lars waits, and the beta amyloid continues its quiet accumulation on the shelf. This is not a flaw. It is a feature of a system that understood. If we can say a system understands anything, that the brain cannot be cleaned while it is in use. The very activity of waking thought, the electrical firing, the metabolic demand, the constant adjustment and response, all of it requires the intercellular space to stay narrow, the astrocytes to stay active, the geometry to stay the way it is during the day. You cannot run the rinse cycle while the machine is still running. So the brain schedules the rinse for the hours when the machine is off. Or rather, not off, never quite off. But quiet, turned inward, running the slow, deep electrical tide of sleep instead of the quick, reactive firing of waking life. Lars moves through the widened spaces. The current carries its cargo outward. The brain, still warm, still alive, still doing the slow background work of being a brain, gets its rinse. It is not a dramatic process. There is no visible rush of fluid, no surge or cascade. Just a quiet, geometry-dependent current doing exactly what it was designed to do, in exactly the conditions it requires. The simplicity of it, once you see it, is almost surprising. It did not need to be clever, it only needed to be timed. The day has loosened its grip. Whatever it was carrying, it can put down now. You are allowed to be finished with it. It did not need to be clever. It only needed to be timed. And the timing, it turns out, is everything. Here is the thing about Lars's work that most people never quite appreciate. The cleaning is not simply switched on when sleep begins. It does not start the moment the eyes close and then run at a steady pace until morning. It rises and falls. It deepens and eases. It follows the shape of sleep itself, and sleep, as it happens, has a very particular shape. Think of it less like a single long exhale and more like a slow tide. Through the night, the brain moves through cycles, each one a kind of arc from lighter rest down into deep, slow wave sleep and back again. The deep part of that arc, the bottom of the tide, is where Lars does his best work. The lighter passages are quieter for him. And so the cleaning of the brain is not a flat, even process. It is a series of waves, synchronized with the waves the brain is already making. The slow waves themselves, those broad, coordinated sweeps of electrical activity that roll across the sleeping brain, do more than signal depth. They appear to actively drive the movement of fluid through brain tissue. Each slow wave seems to create a kind of gentle hydraulic nudge, pushing the cerebrospinal fluid, that clear protective liquid that bathes the brain, a little further inward through the widened spaces between cells. Not a surge, more like a careful, rhythmic press, a bellows very slowly worked. This is the detail that changes the picture entirely. The brain during deep sleep is not passive, not simply a quiet place that Lars moves through undisturbed. The sleeping brain is doing something, actively, that assists the cleaning. The slow wave rhythm coordinates the fluid push. The fluid push moves the waste. The waste is carried outward along the veins. Each step follows from the last, and the slow waves are what start the chain. So when sleep is shallow, when the brain stays in lighter stages and does not reach those deeper, slower rhythms, the chain is never fully started. The fluid still moves a little. Lars still works a little. But the deep flush, the real clearing, requires the deeper architecture. It requires the brain to commit to its own slowness, and that commitment takes time. The first deep sleep cycle of the night is often the richest, the most concentrated. It arrives after the transition from waking, after the lighter, restless early stages have passed. That first long descent into slow-wave sleep is, for Lars, something like the tide finally coming in properly. The channels are widened, the fluid is flowing, the slow waves are setting the pace. And for a period that feels brief from the outside, but is substantial in biological terms, the clearing runs at its fullest. There is a word researchers use for this architecture: sleep pressure. The brain builds it across the waking hours, a growing, quiet insistence, accumulated in the chemistry of the cells themselves, that eventually tips the brain toward deep sleep. Lars knows this. He has, in a sense, always known this. The deeper the sleep pressure built across the day, the richer the slow wave sleep that follows, and the more fully the glymphatic current can do what it was designed to do. This is why a short night rarely feels like half a night's rest. It is often less. If sleep is cut short before the later cycles run, the full sequence of clearing does not repeat. The later cycles of deep sleep, which in a full night arrive after lighter REM passages, contribute their own clearing. Each deep descent matters. A night that moves through its full architecture, shallow, deep, lighter again, deep again, gives Lars the complete course. A night cut short hands him half the work order. None of this is mechanical in the way a factory is mechanical. It is more like weather. The slow waves build, the fluid follows. The geometry of the sleeping brain, those widened cellular spaces, those open aquaporin channels in the star-shaped cells called astrocytes, creates the conditions, and then the waves do the driving. Lars does not force the current. He manages it. He works within a system so well tuned to itself that intervention would only disrupt it. There is something almost architectural about how the brain's slow waves and the glymphatic flush fit together. One produces the conditions, the other fills them. Neither is in charge. They simply suit each other, the way a river suits its banks, not because one was built for the other, but because each shaped the other over a very long time. Lars knows this the way a river knows its bed, not as a learned fact, but as the simple truth of how the work gets done. The slow waves carry the current forward. The current carries the waste away. And the night, given room enough to breathe, takes care of the rest. It is not complicated once you see it whole. It did not need to be elaborate. It only needed to be deep enough. Let the eye stay closed. Let the face go soft. There is nothing left to look at and nothing left to decide. There is a kind of knowledge that only comes from watching something over a long period of time. Not reading about it, watching it. Lars has had that kind of time. He has spent more nights than anyone could count learning the particular behavior of cerebrospinal fluid, how it moves, where it lingers, and what it leaves behind when the current finally slows near morning. And one of the things he has come to understand is this: the fluid does not clean everything equally. The brain is not a single open room. It is a dense, folded territory, closer in structure to a crumpled cloth than to an empty hall. Different regions pack their cells more tightly. Different regions carry more metabolic traffic during the day. And so when Lars arrives at the start of the night's work, the fluid does not spread evenly into every fold at once. It moves along gradients. It follows the path of least resistance, the way any current does. Here is the thing that took researchers a long time to appreciate. The distribution of the night's cleaning is shaped by the architecture of the brain itself. Some regions drain early in the night. Some are reached only after the first long descent into slow-wave sleep has already begun. The fluid does not flood in all at once. It percolates, it seeps. It finds the open channels first, moves through the wider spaces, and gradually works its way into the denser regions as those regions, too, begin to loosen with deepening sleep. This is why a single short stretch of deep sleep, while genuinely useful, does not complete the work. Lars does not get to visit every corner in one pass. The brain is too intricate for that. The night is structured so that he gets several passes, each descent into slow-wave sleep an opportunity to reach a little further, push the current a little more completely through the folded terrain. And here is the part that stays with you once you understand it. The brain's own geography determines its own cleaning order. The regions that do the most demanding cognitive work, the areas associated with sustained attention, with memory consolidation, with the integration of the day's experience, tend to accumulate the most metabolic residue. Beta amyloid builds in the spaces where thinking happens most intensely. And those regions, because they have been most active, may in fact take longer to loosen, longer to open their intercellular spaces wide enough for a thorough current to pass through. Lars knows this. It means the brain's hardest working districts are also the ones that most need the later hours of the night. The hours of sleep that tend to get cut short when the alarm is set a little early, or when the mind finds a reason to surface before morning. The early part of the night clears the easier terrain. The later hours reach the places that have been working hardest, not a luxury, a geography. There is something almost architectural about the whole system when you see it this way. The brain spent its waking hours building a residue map, depositing beta amyloid and other metabolic byproducts in the specific places where the most work was done. And then during sleep, the glymphatic current reads that map in reverse. It clears the residue along routes determined by where the cellular spaces have opened widest, in the order that the night's progression of slow-wave sleep permits. It is, in its quiet way, a form of accounting. The brain tracks what it has used. The night reclaims it. The fluid does not know any of this, of course. It has no intention. It simply moves the way fluid moves, toward lower pressure, through wider channels, carried along by the pulse of the arteries and the gentle hydraulic nudge of each slow wave. The intelligence is not in the fluid. It is in the structure the brain has built around it, the channels, the aquaporin gates, the widening spaces, the whole elaborate scaffolding that sleep assembles, piece by piece, so that something as simple as moving water can accomplish something as intricate as washing the day's residue from the folds of a thinking brain. Lars has always found something settling in that thought. The most sophisticated cleaning system in the known biology of the body runs on gradients and gravity, and the simple willingness of cells to step aside and make room. There is no pump that needs to be switched on, no mechanism that requires maintenance in the waking hours. The whole system arms itself with sleep, clears with sleep, and then quietly disassembles when morning comes and the cells close back up and the day begins again. All that is required is that the sleep be real and deep and long enough for the current to reach the far corners. Lars knows this hour, the middle of the night, the settled dark, the point where the body has fully committed to its rest, and the brain's folded territory is opening, fold by fold, to let the current through. This is when the work reaches its fullest, not at the edges of sleep, where the mind still hovers near the surface. Here, in the depth, the brain did not design this to be poetic. It designed it to be complete. Deeper now. Softer now. The breath keeps its own slow time, in and out, without any help from you. There is beta amyloid, which you have heard about. And then there is tau. Tau is a different kind of problem, or rather, a different kind of passenger on the same current. Where beta amyloid tends to drift loose in the spaces between cells, tau lives closer to the cell itself. It is a protein that normally does an honest job inside neurons, the brain's signal-carrying nerve cells. Its role in ordinary life is to hold the cell's internal scaffolding together, the way ties hold railroad tracks to their bed. The scaffolding is called a microtubule, and tau keeps it stable, keeps the shape of the neuron intact so signals can travel cleanly along it. During a long day of thinking, tau gets jostled, modified, a little chemically altered by the constant activity of a working brain. In that altered form, it can detach from the scaffolding and find its way into the intercellular spaces, the same narrow corridors where beta amyloid accumulates. It becomes, in that sense, metabolic waste. Not bad design, just the ordinary cost of a brain that has been thinking hard. And Lars handles it the same way he handles everything else. He lets the current do the work. The glymphatic fluid, the cerebrospinal fluid flowing inward through the widened cell spaces, does not sort its cargo. It does not decide that beta amyloid is priority freight and tau is secondary. It simply moves, and whatever is dissolved in the intercellular fluid moves with it. Both proteins are carried outward along the venous side of the system, the draining end of the channel that runs alongside the brain's veins. Both depend on the same widened spaces. Both depend on the same slow-wave architecture. Both depend on the same night. This is the quiet economy of Lars's work. 1 current, 2 passengers, no special arrangement required. Here is the thing that makes this worth pausing on. Beta amyloid and tau accumulate at different rates. Beta amyloid tends to build more steadily through the waking hours, a slow addition with every passing hour of activity. Tau shifts in more episodic bursts, a heavier release after concentrated mental effort, a lighter release after a quieter afternoon. The glymphatic current does not know this. It does not adjust its schedule to account for which protein had a heavier day. It simply flows when the conditions allow it to flow, and it clears what is there. That means the relationship between what accumulates and what gets cleared is not perfectly calibrated. It is approximate. It is biological, which is another way of saying it is good enough, remarkably good, over a lifetime of nights, but not a precision instrument. Lars does not clock in with a manifest of exactly what needs clearing. He moves the fluid, and the fluid does the accounting. What nobody tells you is that this makes sleep less like a scheduled maintenance window and more like a tide. A tide does not know what the shore has collected since the last one. It simply rises, moves across whatever is there, and carries some of it back out. The shore is a little cleaner after, not perfectly clean, a little cleaner. And the next tide will come and do the same. That analogy holds in one more way. A tide that does not come all the way in leaves the upper shore untouched. The glymphatic current that does not reach its full depth because the sleep that drives it stays shallow or ends too soon, clears what it can reach and leaves the rest. Not catastrophically, not irreversibly, just incompletely. Lars knows this. The brain, for its part, does not panic about an incomplete tide. It simply begins accumulating again in the morning, and it trusts that the next night will come. This is the implicit contract written into the biology, a daily rhythm of accumulation and clearance, as reliable as breathing when conditions allow. There is something almost restful in that, if you let yourself feel it. The brain does not hold onto the day's metabolic residue out of stubbornness. It holds it because that is what a working brain does, and because it knows, in the mechanical, biological sense of knowing, that the current will come for it. Lars will show up. The fluid will move. The cargo will shift. The tau and the beta amyloid are not problems waiting to become something worse. They are products of a brain that worked, traveling toward a current that is already forming in the quiet of deep sleep. That is their whole story, told in a single night. And here is the finer point. Because tau sits closer to the cell, because it starts its journey from nearer the neuron's own interior scaffolding, it takes a little longer to migrate into the intercellular fluid where the current can reach it. It is not a dramatic delay. But it means that the later, deeper, quieter hours of sleep are not less important than the early ones. They may, in this particular accounting, be the hours that matter most for Tau, when the brain is still, the current is still running, and the protein that takes longer to reach the channel finally gets there. The brain did not design this to be elegant. It designed it to be thorough, same night, same current. More time than you might have guessed. Let the jaw unclench. Let the space between the eyebrows go smooth. Small places hold the day longest. There is a particular kind of quiet that belongs only to deep sleep. Not the quiet of an empty room, not the quiet of an afternoon with the windows shut. A deeper quiet than either of those. The kind that only a brain can make when it has finally stepped back from the work of being conscious. And it turns out that quiet is not just a consequence of sleep. It is a tool. Here is something that does not get said often enough. The brain, while you are awake, is an extraordinarily loud place in electrical terms. Signals fire, neurons talk to neighbors. Whole regions hum with the coordination required to keep a person oriented in the world, to track sounds, to complete sentences, to decide whether the kettle is on. That electrical conversation never fully stops, but in deep sleep, it shifts its character in a way that changes everything for Lars. What happens is this. The neurons, the brain's signaling cells, the ones doing most of the talking, reduce their firing rate significantly during deep sleep. The long, rolling electrical waves of slow-wave sleep, the ones that pulse cerebrospinal fluid through the widened intercellular spaces, are themselves a kind of coordinated silence. A wave of inhibition sweeps across a region, neurons quiet together, and in that collective quiet the tissue relaxes in a way it simply cannot while the conversation is ongoing. The technical term for the electrical quiet in each wave is the down state, a brief, shared pause in neural firing that recurs with each slow wave, somewhere between once and twice every second during deep sleep. It is not a breakdown. It is not the brain failing to do something. It is the brain doing the specific thing it needs to do so that Lars can do his. Because here is the link that tends to get missed. Neural firing, the act of neurons sending signals to one another, consumes fuel and produces metabolic byproducts as a direct result of that consumption. The more a neuron fires, the more it produces. And those byproducts, including beta amyloid and altered tau, do not stay inside the neuron. They migrate outward into the intercellular spaces, the narrow corridors between cells, the same corridors that the glymphatic current moves through. So while the brain is active and firing frequently, it is both generating more metabolic waste and simultaneously keeping the intercellular spaces too narrow for the glymphatic current to move efficiently. The two problems share a cause. Wakefulness is both the source of what needs clearing and the condition that prevents clearing from happening well. Sleep resolves both at once. When neural firing slows during deep sleep, production of metabolic byproducts slows with it. And the same electrical quiet that reduces production also allows the intercellular spaces to widen, the astrocytes, those key supporting cells whose aquaporin channels redistribute water and shrink the cells to open up the channels between them, function most effectively when the surrounding neurons are not demanding so much of them. Lars knows this. The quiet is not incidental. The quiet is part of the mechanism. It is the reason the glymphatic system evolved alongside sleep rather than finding some other window of opportunity. There is no other window. The two states, active wakefulness and effective glymphatic clearing, are chemically and electrically incompatible, not by some unfortunate accident of biology, but by a kind of elegant logic. You cannot run a flush through a busy kitchen. The staff have to step out, so sleep in this context is not simply a permissive condition. It does not merely allow Lars to work the way an empty corridor allows a person to walk. It actively prepares the workspace. The electrical quieting of deep sleep reduces waste production, relaxes the astrocytes into their optimal configuration, widens the intercellular corridors, and sets the glymphatic current moving in the same motion. Every part of the preparation is the same thing: sleep deepening. This is why a night of fragmented sleep, a night of briefly touching deep sleep, and then being pulled back toward lighter stages, is not simply a shortened version of a normal night. It is a night in which the preparation for each cleaning cycle keeps being interrupted before the cycle completes. The workspace is prepared partly, the current begins partly, and then the brain stirs toward wakefulness, and the intercellular spaces begin to narrow again before the current has finished its pass. Lars is patient about this. He does not register frustration in any way that would be useful to describe. He simply resumes as the conditions allow, from wherever the current reached before the interruption. There is always something to clear. The work is never entirely wasted. But the full course, the deep and unhurried pass through the brain's territory, the clearing of both the faster migrating beta amyloid and the slower moving tau, that full course requires a night in which the deep stages are reached completely and held long enough for the current to do its work without interruption. Not a series of brief visits, a sustained stay. The brain generates its own mess. The brain also generates its own cleaning. Both of those are truths about the same organ, running on the same tissue, powered by the same biology. What separates them is simply which state the brain is in. Awake, it makes. Asleep, it clears. It is not a complicated design. It is almost obvious once you see it. The trouble is that from the outside, from the perspective of a person who wakes in the morning feeling either sharp or foggy, the mechanism is completely invisible. The clearing happened, or it did not. Either way, Lars has already put his equipment away. The night does its work without asking for credit. It does not announce when it has finished. It simply delivers the morning. Warmth is spreading through the shoulders, down the arms, into the hands, slow and even like heat through a room. There is a question that sits quietly at the center of all of this. not a dramatic one. Just a practical one, the kind a thoughtful person might ask while staring at the ceiling before sleep finally arrives. The question is, does the brain know how long the night is? And the answer, it turns out, is yes. In its own way, not with a clock, not with a calendar, but with something more immediate than either of those, a running tally of what has not yet been cleared. Here is how that works. Through the night, the glymphatic current moves steadily. It follows the pulse of the arteries. It threads through the widened corridors between cells. It collects what was left behind during the day and carries it outward along the veins. And as it does this, the load it carries changes. The earliest hours of sleep tend to carry the lighter freight, the metabolic byproducts that were already close to the perivascular channels, the sleeve-like corridors that run alongside blood vessels, already positioned near the current when sleep began. Later in the night, the freight shifts. The heavier cargo starts to arrive, proteins that needed more time to drift through tissue and reach the channels. Waste products from the brain regions that the current reaches last, after it has already cleared the easier terrain. This is not a failure of the system. It is the system working exactly as designed. Think of it the way you might think of a deep soak. A quick rinse gets the surface. Time gets everything else. The glymphatic current is not slow because it is inefficient. It is slow because the brain is large, folded, and extraordinarily detailed, and moving fluid through that kind of architecture takes the full length of the night to do properly. Lars knows this. What he has learned over every night the brain has ever slept is that the work is sequential. It is layered. The first clearing makes room for the second. The second clears what the first could not reach. And the final hours of deep sleep are not a bonus round. They are the completion of a process that started hours earlier and could not have skipped ahead. This is where something becomes clear about what sleep duration actually means for the brain. A shorter night does not simply deliver a smaller version of a full night's cleaning. It delivers the early portion of the cleaning, and only the early portion. The lighter freight gets handled. The deeper cargo, the proteins that took longer to migrate, the regions that the current reaches last, those wait. And if sleep ends before the current arrives, they keep waiting, not forever. But until the next long, deep night gives the current enough time to complete its full passage. The brain, in this sense, carries a kind of residue from nights that ended too soon. Not as damage, not as anything that announces itself loudly, just as an unfinished round. A partial clearing that left some of the day's metabolic weight still sitting in the intercellular spaces, the narrow corridors between cells, when morning arrived. And here is the part that has a quiet elegance to it. The brain does not simply tolerate the full length of the night, it uses it. Each cycle of slow-wave sleep, the deep, coordinated electrical tide that rises and falls several times across a full night, gives Lars another pass through the tissue, another run of the current, another opportunity to reach the regions and the proteins that the earlier passes could not quite get to. Each descent into slow-wave sleep is its own clearing event. The astrocytes, the star-shaped support cells that open their water channels and shrink themselves to widen the corridors, do this again. The cerebrospinal fluid pushes inward again. The veins carry more waste outward. The process does not simply repeat. It deepens, it reaches further. By the time the final slow-wave descent of the night has passed, and the brain begins the gradual brightening toward waking, the current has made its full journey. Not just the early terrain, not just the accessible corridors. The whole map. Lars knows this hour. He has been moving through these same passages every night for as long as the brain has slept. He is not sentimental about it, but there is a kind of satisfaction in the completion, in reaching the final channel, in knowing that what was left behind during the long day has now been carried fully away. The brain that wakes after a full night of this is not merely rested in the ordinary sense of that word. It is genuinely clearer. The intercellular spaces are tighter again. The astrocytes have returned to their waking geometry. The corridors have narrowed back to their daytime width. The fluid has drained. The load has been delivered along the venous channels toward the body's wider drainage pathways. What remains is a brain ready to produce more. To think, to process, to fire and connect and make meaning out of the day. And to begin quietly, accumulating the very metabolic byproducts that will need clearing again when the next night finally comes. It is a closed loop. Patient and unhurried, the day fills, the night empties. And the only thing the loop requires is enough time in the night to run its full course. Not a complicated requirement, just an honest one. Everything in the room is exactly as it needs to be. The dark is doing what dark does best. You can let it. The brain is quiet now. Not silent. The heart is still working, still sending its steady signal upward through the body. And that signal matters more than most people realize. Here is something worth sitting with for a moment. The glymphatic system does not move its fluid by pumping it directly. Lars does not have a motor. He does not squeeze the pipes. The force that drives cerebrospinal fluid through the perivascular channels, those sleeve-like corridors around each blood vessel in the brain, is borrowed from the heart. Every heartbeat sends a wave of pressure along the arteries. That wave travels all the way up into the brain. And when it arrives, it gives the fluid in the perivascular spaces a gentle nudge. A small hydraulic push, repeated with every beat, all through the night. The cleaning moves because the heart moves. That is the thing nobody quite expects. The brain's rinsing cycle runs on borrowed rhythm. During the day, that same heartbeat is there. The pressure wave still travels, but the waking brain is too crowded for it to do much good. The intercellular spaces are narrow. The astrocytes are swollen with the business of thinking, and the cerebrospinal fluid has nowhere to go. The nudge arrives, and finds a closed door. In deep sleep, the door opens. The astrocytes have narrowed, the spaces have widened, and that same heartbeat, the same signal that was always there, now drives the fluid forward through terrain that actually yields. Nothing changed about the heart. What changed was the brain around it. Lars knows this. The way a river guide knows that the same current feels entirely different depending on the width of the channel. More space means more movement. The heart provides the current, sleep provides the width, and there is more. The breathing matters too. Breathing is slower in deep sleep, longer and steadier than the quick-shifting breath of a busy afternoon. That slower rhythm creates its own gentle pressure, changes inside the skull, small rises and falls that add a second, softer pulse to the fluid's motion. Not as forceful as the heartbeat, but real. A secondary tide layered beneath the primary one. So the glymphatic current, as it moves through the brain in the deep hours of sleep, is actually driven by two overlapping rhythms at once. The heartbeat's quick, repeating push. The slow breath's longer, quieter swell. Between them, the fluid finds its way through the widened corridors of the resting brain. It is a kind of collaboration that the body never had to arrange deliberately. The heart does not know it is helping Lars. The lungs do not know either. They are simply doing what they always do. But in deep sleep, what they always do becomes exactly what the brain needs. That is worth a moment of quiet appreciation. The cleaning system was not built from scratch. It was assembled from what was already there. The heartbeat was there. The breath was there. The fluid was there. The astrocytes were there. Slow wave sleep was already the brain's own way of resting. Lars did not bring new equipment. He learned to use everything already in the room. The perivascular channels had existed for a long time before anyone understood that they were also drainage corridors. The astrocytes had been managing water balance in the brain long before researchers recognized that the same process widens the intercellular space. The heartbeat had been nudging fluid upward every single night of every person's life, without credit, without anyone knowing it was also powering the brain's nightly wash. In a sense, the glymphatic system is the brain discovering that what it already had was enough. The architecture was already correct. It just needed sleep to activate it. Lars finds this quietly satisfying. Not because it makes his job easier, the work is still the work, but because it means the system is robust. There are no single points of failure. If one rhythm stutters slightly, the other carries on. The fluid does not stop because a breath was held for a second. The brain's geometry does not collapse because one heartbeat varied. The whole system is layered, redundant, woven together from multiple overlapping forces. That layering is part of why deep sleep feels so restorative when it happens fully. It is not one thing being done well. It is several things being done simultaneously, each one supporting the others, each one running on the same borrowed rhythms of a body at rest. The breath slows, the heart beats on. The fluid moves through corridors that sleep has opened. Lars works. There is a particular quality to this hour, the hours that come after midnight, when the body has settled fully into its pattern and the brain's slow waves have found their steady tempo. The heartbeat is unhurried. The breath comes long and easy. The fluid moves with the quiet assurance of something that has done this many times before. Not a new system running its first trial. An ancient one doing what it has always done, in the dark, without announcement. Lars knows this hour. He has worked it more times than can be counted. The same channels, the same borrowed rhythms, the same gradual clearing of the day's accumulated weight. It did not need to be complicated. It needed to be reliable. You are drifting now, slowly and gently, the way a small boat drifts from the shore. No hurry, no direction to hold. It needed to be reliable, and it is. Somewhere in the quiet of the brain, the fluid is still moving. Slowly, steadily, the way water moves through dark soil, not hurrying, not pausing, just following the path that is open to it. Lars knows this. The night has grown deep now. Not the early dark, when sleep is new and shallow. The real dark. The kind that settles into a room like something patient and old. This is the hour Lars was built for. The intercellular spaces, those small corridors between the brain's cells, are as wide as they will get. The astrocytes did their part hours ago. They shifted their water, drew themselves in, made room. And the room is still here, still open. The cerebrospinal fluid moves through those corridors now. Not fast, not dramatic, just a gentle current, the way a quiet river moves in the hours before dawn. The heartbeat sends its small pressure wave. The breath rises and falls. Those two rhythms, borrowed from the body, not invented by the brain, keep the current going. They were always there. Sleep just gave them a channel. And so the fluid moves. Somewhere in the brain's deeper architecture, in the folds that the current reaches only at this hour, the work continues. Beta amyloid, lifted from its resting place in the intercellular space. Tau, migrated from its origin near the neurons, finding its way at last into the channel. Both of them carried now, both of them moving toward the veins that will carry them away. Lars does not rush this. He never has. The slow waves of deep sleep, those broad, coordinated electrical tides, are still rolling through the brain, quietly, like swells on a very calm sea. Each one nudges the fluid a little further inward. Each one is another part of the current through terrain that needed the whole night to become reachable. This is not a new idea to Lars. It is simply how the night goes. The brain is quiet. The neurons, so busy all day, are resting now. Not switched off, never fully off, but still. The way a city grows quiet after midnight, the traffic thins. The signals slow. The air clears just a little. And in that stillness, the fluid moves more freely. Lars knows this dark. Earlier in the night, the current swept through the easier terrain. The corridors closer to the surface, the spaces that fill first and clear first. That work is done. Finished in the first long descent into deep sleep, and then again in the second. What remains now is the slower work, the deeper clearing, the parts of the brain that only open their doors when the night has been long enough and still enough to reach them. Lars moves through these corridors the way someone moves through a familiar building after hours. No need to rush. He knows which way the current runs. He knows where the fluid has already been and where it is still going. The perivascular spaces, those sleeve-like channels running alongside the blood vessels, are carrying the collected waste outward now. A quiet procession, beta amyloid, tau. The ordinary leftovers of a day of thinking and feeling and remembering and noticing. All of it on its way out. Not a flood, just enough. The brain does not need to be scrubbed. It needs to be rinsed. And a rinse done properly, done slowly, done through the deep hours with all the right conditions met, that is sufficient. It was always going to be sufficient. Lars knew that from the beginning. The breath in the room is easy now. The weight of the body has settled fully. The mind, if it wanders at all, wanders slowly, drifting rather than walking, noticing rather than thinking. That is exactly the condition Lars needs. That is exactly the brain that the glymphatic current moves through most freely. Still, open, resting. The fluid moves. The slow waves roll. The heartbeat sends its steady pulse. The breath rises and falls. And Lars, moving through the brain's quiet corridors in the deep hours, does what he has always done. He clears. Slowly, without ceremony, the way good work is usually done. You are further from waking now than you were a few minutes ago. That is the whole direction of travel. Just down and quieter. Without ceremony, the way good work is usually done. And so the night deepens. Not suddenly. Gradually, the way a tide comes in, so slowly you almost miss it, until you look down and find the shore has changed. The brain is quiet now, truly quiet, not the quiet of waiting or of holding something back. the quiet of a room where everything that needed doing has been underway for hours, and the work is simply continuing, steady and unhurried in the dark. Lars moves through it all, corridor by corridor, space by space. The cerebrospinal fluid, that slow, clear current that carries the day's leftovers outward, still flowing, still gentle, still doing what it has always done in every brain, on every quiet night. The intercellular spaces, those narrow corridors between the brain cells, are still wide open. The astrocytes, the cells that manage the corridors, are still holding them that way. Water redistributed, geometry shifted. The pathways clear. It is not dramatic. It never was. Somewhere a heartbeat moves through. Steady, unhurried. Its pressure wave nudges the fluid onward, just slightly, just enough. The breath rises and falls. That slower rhythm, the long swell of deep sleep breathing, adds its own quiet push. Two borrowed rhythms, neither one aware it is helping, both helping anyway. This is the thing about the brain's cleaning. It asks nothing new of the body. It uses what is already there, the pulse, the breath, the geometry of sleep, and simply lets them work together. A system assembled from pieces that were always present. Sleep is what brings them into alignment. Lars knows this. The beta amyloid, the protein fragment that drifts into the intercellular spaces during a long day of thinking, is still being carried outward. Along the perivascular channels, the sleeve-like corridors that wrap around the brain's blood vessels, it moves toward the exit. Slowly, without urgency, the current is unhurried and the cargo goes with it. And the tau, the scaffolding protein that takes longer to find its way from the neurons into the open channels, is still traveling too. It needed the later hours, the deeper hours, the hours that only a full night provides. And here they are. Here they are. The slow waves of deep sleep, that great coordinated electrical tide that moves across the brain in long, rolling cycles, are still arriving. Each one a quiet push. Each one widening what needs to be wide, moving what needs to be moved. Not forcing anything, just accompanying the process. The way a gentle current accompanies a leaf downstream without the leaf noticing. The brain does not notice either. It is elsewhere. It is resting in that deep, still place that sleep carries it to, while below the surface, the work continues. There is something worth sitting with in the idea that the brain cleans itself. That after a long day of thinking, of remembering, of solving and worrying and noticing and forgetting, the brain spends its night doing its own housekeeping. Not because anyone told it to. Because it always has. Because the system was built into the architecture from the beginning. And Lars, the patient one, the one who waits all day and works all night, is simply the name for that system. For the current, for the corridors, for the slow, dependable rinse that happens while you sleep. Let your breath be easy. Let the weight of your limbs settle. The brain above you, the one that carried the whole day, is open now. Its corridors are wide. Its fluid is moving. Its borrowed rhythms are doing their quiet work. Nothing is needed from you. Not effort, not attention, not even awareness. The cleaning does not require you to witness it. It only requires you to stay asleep, and you are. The night is not finished yet. There are still corridors to move through, still fluid flowing, still the gentle back and forth of pulse and breath, keeping the current alive. But there is no hurry. There never was. Lars knows this dark. He has always known it. Every night the same corridors, the same quiet, the same borrowed rhythms doing the same steady work. The same brain, open and still, letting the current carry the day away. Good work. Unhurried work. Work done without a word in the deepest part of the night while everything rests. Everything is quieter than it was a moment ago. Even the small sounds have gone soft around the edges. Unhurried work. Work done without a word in the deepest part of the night while everything rests. And now, somewhere in the quiet hours before morning, the circuit nears its close. The cerebrospinal fluid has moved through its channels. The intercellular corridors, those small, widened spaces between the brain cells, have carried their passengers outward. Beta amyloid, gathered from the places where it settled during the long day. Tau, coaxed slowly from its origin near the neurons, finally moved into the current and carried along. All of it drifting outward through the perivascular spaces, the sleeve-like channels alongside the veins, and away. Lars does not announce this. There is no signal, no marker, no moment when the work declares itself finished. The fluid simply keeps moving. The borrowed rhythms, the steady pulse of the heart, the slow rise and fall of the breath, continue their quiet driving as they have all night, asking nothing in return. The brain lies still, open, its geometry settled into the shape sleep allows. The astrocytes, those star-shaped support cells that hold the architecture of the brain together, remain drawn back just enough to keep the corridors wide. They will return to their daytime form when morning comes. But morning is not here yet. For now there is only this, the fluid, the current. The quiet, Lars knows this hour. He has worked it many times before, in many different brains, across many different nights. He knows the particular stillness of a brain that has let the day go. He knows the difference between a mind that is resting and a mind that is merely waiting. Right now, this brain is resting. The slow waves that drove the deepest clearing have done their work. The corridors have been walked. The cargo has been carried out. This is what the night was for. Not rest as an absence of something. Rest as the condition that allows the most essential kind of work to happen. The brain was not switched off, it was opened, and Lars, patient as ever, moved through every part of it. While you sleep, Lymphatic Lars is already at work. Cerebrospinal fluid, the clear, gentle liquid that flows through and around the brain, is moving right now through widened intercellular spaces, collecting the metabolic byproducts the day's thinking left behind. Beta amyloid, the protein fragment that accumulates while the brain is busy, is being carried outward through the perivascular channels along the veins. Tau, the scaffolding protein altered by a full day of neural firing, has migrated into the current and is moving with it. The astrocytes are holding the corridors open. The heartbeat and the breath are lending their rhythm to keep the fluid flowing. The whole quiet system is running right now in the dark, without any effort from you at all. You don't have to do anything. Your body knows exactly what to do. It's been doing this work for your entire life. Every single night. So let it, trust it. And as you drift deeper now, Lymphatic Lars will be here when you wake up. Quieter, calmer, better, sleep well.